I also want to thank Dr. Meza for, we wouldn't be here without him, without his help with this study. So I'll be talking about laser-assisted irrigation in a root canal. So the purpose of using the laser in the root canal is, of course, to improve the effectiveness of the irrigants, remove smear layer, improve disinfection, get into deeper penetration into the dentin. There are many studies that compare the effectiveness of a laser to conventional treatments, but it's very few studies actually compare multiple different technologies in the same study, and it's difficult to compare multiple studies to each other because methods are different. We thought to have so I'll be presenting on a pilot study that compares multiple technologies versus the needle irrigation. So we're following this Galler study that was published about 4 to 5 years ago. They're using methylene blue as an analog for sodium hypochlorite, in how deep sodium hypochlorite can penetrate into the dentin. And you can see these beautiful pictures that they have. MDA is needle irrigation, is what they're calling needle irrigation, passive ultrasonic, and they're comparing it to an Erbium-YAG sweeps technique. For their study, they showed not much difference between the three groups, and we thought, let's expand this, add the water lace, or also an erbium laser treatment arm. So we repeated their study, and our aim is basically the same as theirs, explore how deep the penetration depth of methylene blue dye into the dentin, following root canal treatment with needle irrigation, Erbium-YAG sweeps, and erbium chromium water lace. So we're using extracted maxillary lateral incisors only. They were all standardized to the same 12mm length, instrumented to 2504, cleaned, irrigated with sodium hypochlorite, EDTA. Then we sealed the outside surfaces of the root canals. These also sealed the apex of the root canal, therefore creating a closed system, closed root canal. We also wanted to standardize the root canal length for each sample that we're using. So we created, so each root is 12mm in length. We created this acrylic model here so that it's not to scale. The top and bottom are actually almost the same length. So the top chamber is a 6mm model pulp chamber that is drilled into acrylic, followed by the model canal, which meets up with the extracted tooth that is placed into this bottom chamber. All surfaces of the acrylic model are sealed and waterproofed, so any interface is sealed and waterproofed. Therefore, so the only place that we want the methylene blue irrigant to go is in the root, in the dentin. And the red, this is the laser tip. We're comparing the placement of the laser tip with the different technology. So we have water lace, which goes to about 5mm into the extracted root with the RFT2 tip. The RFT3 tip goes to about 1mm into the extracted root, and the Erbium-YAG sweeps tip is placed in the pulp chamber just above the canal, the model canal opening. All of the groups are irrigated with methylene blue dye. We standardized the treatment time to 3 3 minutes total for every group. So 30 seconds of active irrigation with 30 seconds of rest and 3 cycles of those. The laser irrigation group, while we're irrigating with the needle, we're also assisting the irrigation with the laser treatment, and that's for the erbium sweeps, that's from the canal orifice, and of course with the 2 water lace groups, that's from 5 millimeters, 7 millimeters from the apex of the extracted tooth, and then 1 millimeter into the extracted tooth. So basically, the RFT2 and RFT3 are close to the where I will be cross-sectioning that tooth. So next we removed, so immediately after irrigation, we removed the extracted tooth and rinsed and dried, then cross-sectioned at about 5 millimeters from the apex. So the RFT2 tip is about 1 millimeter away, and the RFT3 tip is about 5 millimeters away from that cross-section. We're measuring dye penetration. For each sample from each group, we're measuring 20 points from starting from the canal wall, radiating outwards as far as the methylene blue is visible. These are some sample images. Each image is a different tooth cross-section. We have results of the needle irrigation, the sweeps, our water lace with RFT2 and RFT3. There is, well, I will show results here. There is a marked difference for the RFT2 and RFT3 tips, about twice as far. And I'll talk about why we think that happens. You can see the maximum penetration for each group. That is one measurement. That is the deepest that we recorded the methylene blue into the dentin, penetrating into the dentin. And I just want to mention, so there are multiple studies showing pretty similar results, and we believe that there is a reason for why this penetrates deeper. So we have the mode of action, the laser. Each laser pulse, the 2 lasers, they're both erbium lasers. They work more or less the same way. Each laser pulse first deposits a huge pressure increase. You can see the spike here before time 0. That pressure generates a large vapor bubble. This is on the scale. You can see 1 millisecond. The vapor bubble grows, collapses. The collapse also generates large pressure. This is inertial cavitation. Each collapse generates pressure. The closer that pressure is to the target tissue, the more effective it is. But we also know, so this results from a previous study that we worked with a laboratory in Washington State. We know that the pressure dissipates in water with distance. So for every 5 millimeters away from the energy source, the pressure halves. So you can see from 0 to 5 millimeters, you're losing about half of the pressure. 5 millimeters deeper, it's half again. And further in the canal, this pressure transfers and travels along the canal. It creates shear stresses. That shear moves along the boundaries, the canal walls, generates these tiny cavitation bubbles. The cavitation bubbles actually are the ones that last a long time. So the big bubbles you never see. You can't see with the naked eye. They're too fast, milliseconds. The cavitation bubbles, they last a while. They're expanding, contracting, and those are the ones that you actually see down further in the canal. They are helping to clean the canal, remove smear, and pull bacteria, but they're not very high, they don't generate very high pressure. So they do help to clean, but they do not push the sodium hypochlorite deeper into the canal or into the dentin. The two lasers, like I said, basically for all intents and purposes, work the same way. They both generate this large bubble at the tip, generate more or less the same pressures. The real difference is where you place the tip, and other research also shows the same so this publication, 2016, they looked at debris scores using the erbium YAG. They found that the closer you place the tip to the debris in the canal, the more effective it is. So if you place it near the canal, the groove in the canal with the debris, it removes the most debris. If you place it in the pulp chamber, it is the least effective. Same with this research. The important part from this group is if you place the tip of either device, both erbium lasers, if you place it against the dentin, they are equally effective. But if you compared to sodium hypochlorite alone, adding the laser and placing it against the dentin, you get double the penetration of sodium hypochlorite needle irrigation. And so these are results from another study that we did. So you can see the penetration depth using the erbium water laser. It is much deeper than the EDTA and sodium hypochlorite alone. These are confocal microscopy images. So in summary, the closer the needle is placed, or the laser tip is placed to the target, the more effective the treatment is. So with the water lace, you're able to bring the very small diameter tip into the canal and remove more material and penetrate deeper for the disinfection.
Thank you so much for that. That was really informative. Questions from the audience? Yep, Dr. Beckett.
Yes, I think maybe something that with this technique, sometimes if you go too close to the apex tip, you can generate cavitation bubble, which can maybe have some issues with the periodontal apex or extrapolate.
Mm-hmm.
Can you just expand on that for me? And what's your working length with this?
So in the model, so the pulp chamber is about 6 millimeters. The canal that was instrumented, the cylindrical canal that was created in the acrylic was also 6 millimeters. And then the tooth root that is extracted is 12 millimeters. So the full root is 18 millimeters long. We haven't had, so if you're generating cavitation bubbles all throughout the canal, anywhere further from the tip, and they're moving around. They're constantly in action. You can see them if you're looking at the model, the transparent practice teeth.
So how far down from you working as do you recognize to use your laser for this technique? And so you work within 1 millimeter away from the teeth, 2 millimeters, 3 millimeters to
Right.
solve that problem that's being reported in relationship.
Oh, which problem?
This cavitation bubble that apparently can have some issues extrapolating on the
I think she's concerned about
Periapical.
Extrusion from the
Yeah,
apex?
apex.
We haven't had any adverse events reported.
I guess, Alina, the question is, do you limit your working length to reduce the periapical extrusion?
Yes, so I was getting there.
Yeah.
So we haven't had any adverse events of extrusion. We have, with the settings that are used in the study, is the output of the tip is controlled to. So the output from the tip is about 13 millijoules. For both RFT2 and RFT3, so you can use the tip anywhere from 1 millimeter from working length to 5 millimeters away. And what we like to tell doctors is to, if you have a curved canal or any blockage, to say at least a millimeter away from that curvature.
So 1 to 5 millimeters
1 to
from the
5.
working length, that's the safety zone that they're recommending.
And we've done several million cases with no reported extrusion. Yes.
Dr. Zell?
What's the concentration of methylene blue that you use? I missed the first slide.
1%. It wasn't diluted. It was as it came.
1%.
It was the same for each group.
Well, I'm a physicist.